Lesson 26 compared to the previous lesson, everything is a complete twin replica of everything we've been doing about dilatations, but now we no longer know which one is the original and which one is the image. You get to pick. So make sure that you're just labeling. You're actually going to be doing, you're going to just basically correspond ABC triangle to DEF. They're similar. So because they're similar, they're exact twins of each other, but one is bigger or smaller. They're just not attached by dilatation lines. So remember my scale factor, if it's below the number 1, it's getting smaller. If it's above the number 1, it's getting bigger. Exact replica is like, 100% on a photocopy machine, or it's that perfect 1, which we don't really do because we're not redrawing and saying times 1. It would be the exact same thing. So remember that in similar, compared to dilatation, we have 3 things. So similar, everything, corresponding angles, they are exact same size, and also the corresponding sides are proportional. And to prove this, right, we just do scale factor. Now, if it was dilatation, we had one more thing here. If it was a dilatation, dilatation includes that everything is parallel because of those dilatation lines, where you can actually have an image rotating compared to the dilatation, which everything was fixed, nothing got rotated, all our lines were actually exactly the same. Now, if I use a first example, you can see it as in a table, you can see it actually in shapes, so we'll do both here at the same time. So if I do have just triangle ABC, they're similar to DEF, so I know that the angles would be the exact same thing. They would have to tell you that, what the angle numbers were. So this angle goes with this angle. This one is perfectly the same as this one. And that last one with double slash would be the same thing as this one. So just look at the angles. It's very easy to do that. And the language behind angles, you would say that angle C is equal to angle F, for example. You could also have it here, DEF may be labeled, comparing it to ABC. And maybe you have those numbers in there, 4.5, you have a 3, a 4, and maybe you have a 7.5 here. So if we go ahead and label these, each one only has 3 sides. So for example, if I look at ABC, it has a 3, 4, and 5. So you could see that actually in the image. So let's say I have 3 and 4 here. I'm missing this one. And in this one here, I have this 4 is missing. The 4.5 goes with the 3. And this one here, I have the 7.5 that goes here. And I need to either look at the image that I drew in red or look at my table to fill in. Now, they didn't give me a scale factor, so you need to pick what your scale factor is. You could keep it as is, I over O, so therefore DEF is your image and this is your original. So you label it, that's the only difference. So then you know if I pick on corresponding sides, 4.5 divided by 3, so when I divide that, right, so 4.5 divided by 3, 1.5. So my scale factor is 1.5 because I'm dividing, right, I over O. You pick which I is over and over. Then you know. If you decided that this was your original and this is your image, you then know how to travel. Old to new, multiply scale factor. Image back to the original, you are dividing the scale factor to fill that in, okay? The bottom of the page here, if it tells you to prove something, remember, proportional angles, you just look at the angles. Easy. They do have to label the numbers for you to say that they're exactly the same thing. If it's corresponding sides, the way to prove this right, is doing scale factor of all sides involved.